What can you understand as a virtual local area network? I configured VLAN on this device. You can understand a VLAN as a virtual switch. I configured a VLAN 10 on these few interfaces. You can understand it as. Now physically you see this switch. It's like cutting it in the middle. For example, the 4 interfaces on the left are assigned to VLAN 10. You can understand that this is 2 switches. It's like cutting the switch in half. This half is a switch. The other half, for example, are all VLAN 20. Although you see it as a device, but actually it has split. You can understand it as a different switch. In fact, there are many ways to divide VLANs. For example, based on MAC. Even IP-based. Including policy-based. But the one we use the most in our projects. VLAN division based on interface. For example, I now have many interfaces on this device. 1 to 48 interfaces. 48 port switch. We can usually divide the 15 interfaces. From 1 to 15 to the technical department. 15 interfaces from 16 to 30 are assigned to the sales department. 30 to 35 these interfaces are divided into the personnel department. The rest will be allocated to the logistics department. Leave 1 or 2 interfaces for redundancy. This is called interface-based VLAN division. Suppose I assign the technical department to VLAN 10. I assign the sales department to VLAN 20. Assign the personnel department to VLAN 30. This is how we divide. We'll do the configuration later. Let's start with the concept. This division is artificially divided by configuration. Pay attention to my words. Artificially divided by configuration. That is, you need to enter this interface. Then divide it into the corresponding VLAN. Then this interface belongs to this VLAN. It's simple. Between different VLANs, unknown unicast data frames can be isolated. Broadcast frames can also be isolated. Data flooding will not pass through different VLANs. Then one might ask. These 15 interfaces are technical department. Then if there is a virus in one of the data or a PC, what about sending to other devices? Okay. They also get infected. But we narrowed down the scope of the infection as much as possible. Originally 48 devices may be infected. Now you have divided the VLAN. Only these dozen or so devices are infected inside. So narrowed down. It's not that you divide the VLAN. There will be no forwarding of the virus. That's not what it means. You need to know. What we have to do is control as much as possible. I mentioned the structure to you before. Access. Converge. Core. VLAN will be configured in the access below. We will configure gateways of different VLANs on layer 3 switches. But there is no concept of 3-layer division VLAN. This is the access layer switch. They will divide VLAN here. For example, this is VLAN 10. This is VLAN 20. In the future, we will be here on the aggregation switch above. The gateways corresponding to VLAN 10 and VLAN 20 will be configured here. But we will not divide the VLAN in the 3rd layer. VLAN is a concept belonging to the 2nd layer. So, this technique is very common in corporate networks. In the corporate network, switching technology is much more common than routing technology. Because every enterprise must have a switch. But each enterprise does not necessarily have multiple routers. This is the application direction of their technology. This is a flexibility of what we call VLANs. That is, between different floors, we can achieve. Different floors can communicate across switches. Let's discuss how VLAN is implemented. I now ask you a question. Port of this switch. different devices are connected under it. For example, now both of them are not in the same VLAN. Then please. The device on the left acts as a PC. Does it know whether it is in the same VLAN as the device on the right when sending data? Okay. It doesn't know. So for end users, we only guarantee the most basic data communication. Specifically, what VLANs are they? It doesn't care. So when the PC is actually sending data, it doesn't know which VLAN it is in. It is totally unknowable. The operation of VLAN is configured on the switch. It is a technology deployed on the switch. Let's take a look at the process. For example, now PC1 sends a broadcast ARP. Suppose it wants to ask a user on the same network segment 1.2 of this MAC. Because we did not configure the gateway, we will not go to the third floor for now. The device on the left sends an ARP to ask the device on the right. The switch received the ARP data. How does it tell which VLAN it is based on this data? For example, I now assign 1.1 to VLAN 10. 1.2 in VLAN 11. They do not belong to the same VLAN. Then this data should not be forwarded. Although it is an ARP broadcast, but it belongs to cross VLAN. Then how does it know that this data belongs to VLAN 10? Everyone think about this question. The data sent by the PC does not know what VLAN it belongs to. I have to operate on the interface of the switch. That is, data is sent to the switch here. When coming in from the interface, we want to add a tag to this data. It is a field. The above is a standard Ethernet 2 message. A total of 18 bytes. This part is the frame header and frame tail of the second layer E2. Data is the data part. This tag is inserted between the two of them. This type indicates what protocol the upper layer is. This is the destination MAC and source MAC in the second layer. And checksum. Then the overall tag is embedded in the overall data frame. The tag is not just a VLAN ID. It contains a lot. But these things are not very important. First there is a TP ID. It represents the 802.1Q we will talk about today. 802.1Q is also called .1Q. We will configure this thing when we do configuration today. It is a data encapsulation standard. Is a type of publicized tag. Cisco actually has its own proprietary, called ISL. But we hardly use this now. In fact, the proprietary technologies of various manufacturers are not used very much. We are now using public. So it identifies the what kind of tag type do we use. Further down here there is a priority. It represents the priority of VLAN data. In the future, you will learn the IE stage. Learn this field when you learn QoS. Let's not look at this stage. Further down is CFI. It represents whether this frame is a standard format. A CFI of 0 represents the classic format. A CFI of 1 represents a non-classic format. It's almost classic now. So we don't need to look at these parameters now. The most critical is this VLAN ID. This is the switch. This is a PC. PC sends a data. When the data arrives at the switch interface, the PC will carry the VLAN ID. Then there is a 12B written in the VLAN ID. Represents 12 bits. VLAN ID has a range. 12 in total. Each bit has two values 0 and 1. This represents the number of VLANs you can create on the switch. You divide an interface into a VLAN. A data enters this interface. Enter the corresponding VLAN ID. This VLAN has a range. Each bit has two values 0 and 1. There are 12 bits. A total of 2 to the 12th power. A total of 4096 combinations. That is, a total of 4096 LANs. But 0 to 4095. This is a total of 4096. Start from 0. Computer languages start with all zeros by default. So it ranges from 0 to 4095. Among them, 0 and 4095 cannot be used. The VLANs we can create are 1 to 4094. This is the range of VLANs we are able to use and create. Remember this. You have no way to create a VLAN larger than 4094. In addition to the VLAN ID we mentioned above, there is another concept. Link type. Let's go back to this picture. For example, we are not giving this device an IP address now, regardless of whether it is a network segment. Assume now go through layer 2 communication. The data arrives at the switch here. Since the behavior of this tag is done by the switch, then think about it. It sends this data to the PC on the right with this tag. Assuming they are both in the same VLAN. Can you send it over? Okay. This is not allowed. Let's take a look at this picture. First you need to know. PC can't recognize tag. I had a student ask me a question before. PC does not recognize the tag. Then don't look at this field. Okay? Just skip it. What I want to say is, our equipment is not so smart. The data frame read by the device is 01010101. A normal data received by PC. After reading the destination MAC and source MAC, you should continue to read type. So if the device sends a data frame with tag, other devices will interpret the data frame according to the type. Then it will find that it does not understand. Because there are 2 bytes in the original type. The first 12 bytes have been read. The 2 bytes of type should be read. As a result, these 2 bytes have been read. It found that this does not seem to be type. Then it means that the data frame cannot be understood. If you don't understand, there is no way to read this data frame device. If it can't be recognized, it can only be thrown away directly. Because reading data is read one by one, including the type in the second floor of our study. The protocol in the 3 layers. It's all about pointing out what the upper layer is now. For the sake of, after reading the second floor, if the third layer is the IP protocol, to read one by one field in the IP header, there are rules. So we often say, the lower layer indicates the upper layer, is for upper class service. When data is read, do you know what kind of data encapsulation standard to read the upper layer data? So this tag is sent to PC. It has no way to recognize. This packet can only be lost. Therefore, it cannot be sent to the PC with the tag. This thing is only recognized by the switch. I said it before. VLAN is deployed on the switch. Only the switch can recognize it. The router can also recognize. But you have to do other configuration. Today we will talk about how to configure.